Howdy, howdy, howdy. We are at the mid-chapter review. Cool, cool, cool. There is an answer key for the test yourself portion of this work booklet that you guys are completing, or maybe already have completed. That's totally cool. I thought just in case something wasn't making sense, I'd make a little answer key video. So let's say you got question 1 and 2 correct. Cool. You can skip past that portion of this video. But question 3, I got it wrong. And I don't understand how I got it wrong. I don't understand why it's whatever answer it is. Well, that's why this video exists. So you can use this video to help you understand where you went wrong, and more importantly, how to fix that mistake. So let's do this thing. So question 1, it says, which fraction is equivalent to 2/3? Okay, well, I can prove this in a number of different ways. Number 1, I can use visual diagrams. And you know what? I'll use the old the hexagons that we've been practicing with. And you guys all have those bags of shapes in your desk. So you guys could absolutely use this, okay? I know that blue, these little diamonds, okay, those are my thirds. So 2/3 would look something like this. It's gonna look a lot better with your shapes though. Those are kind of hard to draw, for me at least. Okay, so 2/3 here, okay? Well, what if instead of doing the diamonds, I use those little triangles? Okay, well, I got 2, 3, and 4. So we can see how these are pretty close to being equivalent. Okay, well, this was 2/3, and this was 4/6. Okay, so what's equivalent? It is 4/6. So visually, I can prove that. Okay, but I don't have to use visuals if you don't want to use your shapes. If you'd rather do it symbolically using numbers, that's totally cool too. So 2/3. Let's multiply it. I would never go times by 1 because that's just going to be 2/3 again. So let's multiply it by 2. Remember, you have to multiply both your numerator and denominator by the same number. 2 times 2 is 4. 3 times 2 is 6. Hey, check it out, 4/6. We did it. Cool. If I really wanted to, I could use my fraction strip tower that I have on my desk. Okay, and I'm talking 2/3, right? Cool. So I find my thirds, 1, 2, 3, and I will shade in 2/3. And now I just got to kind of scroll down. Scroll down. Oh, sorry, pardon me. Scroll down until I can find an equivalent fraction. So that's going to be a line that matches up with that. Okay, that doesn't work. That doesn't work. Hey, check it out. That works. Cool. What fraction actually is this? Well, there's 1, 2, 3, 4, 5, 6. 6 total. And how many is that shaded in? 1, 2, 3, 4. 4/6. Hey, check it out. These are equivalent to each other. Cool. So there you go. 3 different strategies for proving the 2/3 actually is equivalent to 4/6. And what I like about this fraction strip tower, we can also see that the other answers, so 3/4, we can see that the other answers are actually wrong, right? Because 3/4 is to here. 3/4. Not even, not equivalent. Okay. What else do they have there? 2/6. Okay, so 2/6 would have just been to here. That's got to be wrong, not equivalent. Same thing with 1/3. Oops, pardon me. 1/3 is just from here to here. Okay, so a pretty cool visual. But again, any of those strategies will work for you. Moving on. Let's delete that. I'm going to clear off all this junk for us. There we go. Question 2. Which equivalent fractions describe the gray parts in the picture? Well, firstly, I'm going to count all of these. So I see 1, 2, 3, 4, 5, 6, 7, 8. How many are gray? 1, 2, 3, 4. Okay, so that's one fraction that represents this diagram. I can also regroup these. So I can regroup this into one group, all the whites into one, all the grays into another. How many groups do I have total? 1, 2. How many of those groups are gray? 1. And there you have it. There's your answer right there. 4/8 is equivalent to 1/2. Continuing. Question 3. 8/10 of the counters below are shaded. What other fraction can you use to describe the shaded counters? So this is very similar to that question we had up above here. Notice that they've kind of already grouped these really nicely for you, so we can just regroup these pairs. So instead of counting each and every single circle, which is 10 circles, I can count the groups. So I got 1, 2, 3, 4, 5 groups. And how many of those are shaded? 1, 2, 3, 4. 4 groups. Boom. So we can say that 4/5 is equivalent to 8/10. And if I want to do this symbolically, I can show that by timesing this by 2, doubling it. 4 times 2 is 8. 5 times 2 is 10. Cool. Moving on. Question 4. Use a number line to order these fractions from least to greatest. We've got 4/5, 1/4, 1/5, 2 quarters. Yeah, sorry. Okay. So notice they've already given us this beautiful number line right here. So that's going to really help us. So let's have a look at 4/5 first. Let's see if I can find it. Ooh, 4/5 right there. Boom. Okay, I'll use purple for that. Let's use blue for 1/4, 1/4. Ooh, right here. Boom. Okay. So notice 1/4 is already less than 4/5. Okay. I'll use pink for 1/5. Ooh, there's 1/5. Cool. It's the smallest. 1/5. And then 2 quarters. I'll use orange. Where is 2 quarters? There it is right there. Okay. Excuse me. So here's my order. I've got 1/5. I'll use a comma to separate my terms. Then I've got 1/4. And then I've got 2 quarters. And then lastly, that must be, yep, 4/5. There's my organized fractions, and I'm using a fraction, or rather a number line to help me organize them. And which one is that? Where's 1/5? Not that one. Is it this one? 1/5, 1/4, 2 quarters, 4/5. Yeah, it's that one. I'll double check these to be safe. Nope, we don't start with 1/4, and no, we don't start with 4/5. Cool, so it's B here. Awesome. Moving on. I'll erase everything. Question 5. Which comparison is correct? 1/3 or 1/6, 1/2 or 4/5, 1/5 or 3/10, or 9/10 or 4/10. Okay, well, we're looking for the correct one. Now, we can use fraction strip towers to help us. We can use diagrams to help us. We can use number lines to help us. And absolutely, if you want to use any of those strategies, I think that's brilliant. Good on you. Those are all great strategies. But before we do that, again, keep in mind that your time is valuable. So what are some ways we can actually just look at these fractions with our eyes and see if it's correct or if it is incorrect? Okay, well, take a look here. Both these fractions are like fractions. So what that means is they have the same denominator. And since they have the same denominator, I know I'm talking about the same size chunks. So 9/10 and 4/10. Well, if I go down here to my fraction strip tower, here are my tenths, okay? 9/10 is 9 of them, right? 9/10. 4/10 is just 4. And since they are all tenths, right, I can compare them pretty darn easily just by looking at them. They've got common denominator, the same denominator. So I know that this has got to be wrong. 9 is more than 4. 9/10 is more than 4. So that one's wrong just by looking at it. And thankfully, it has a common denominator. It makes it really easy. But look at C. It's got different denominators. These are unlike fractions. So that makes them a little bit trickier to compare. So I can use my fraction strip tower, but I won't this time. I'll use a different strategy. So I'll go over here. Okay. So 1/5 and 3/10. I don't like that they are unlike. I want them to be like. I want them to have a common denominator. So what can I do? Well, how can I turn this denominator into a 10? Well, I can multiply it by 2. I got to do it with the numerator too, though. 5 times 2 is 10, and 1 times 2 is 2. So now I've got 2/10, comparing that with 3/10. Which one's bigger? Ding, ding, ding. 3/10, of course. 3/10 is bigger than 2/10. So look at that. Check it out. This one's saying 3/10 is greater than 1/10. So this one could be correct. Just to be safe, I better check my other questions. Okay. Look at B. Unlike fractions. They don't have the same denominator. So that makes them hard to compare. Okay. So 1/2, 4/5. How can I make these have the same common denominator? Well, I can't multiply 2 by anything to make it into a 5. Well, no whole numbers at least. So what I'll do is I will multiply it by the other fraction's denominator. which is 5. I'll multiply this one by the other fraction's denominator, which is 2. So I'm just kind of swapping denominators here. 1 times 5 is 5. 2 times 5 is 10. Same thing over here. 4 times 2 is 8. 5 times 2 is 10. And check it out. Now that we have like fractions with a common denominator, we can clearly see that 8/10 is bigger than 5/10. So therefore, 8/10 is bigger than 1/2. And that is not what's being said here. So that's wrong. Okay, let's keep moving. We've got 1/3 is less than 1/6. Ugh, I don't like that. Doesn't look correct to me, but let's prove it. It's not good enough just to have a guess. Let's prove it. 1/3, 1/6. Okay. Let's find the thirds. Here are the thirds. Boom. Let's find the sixth. Oh, darn. Sixths are 1, 2, 3, 4, 5, 6. Yeah. Here. Oh, no, those are fifths. What am I saying? These are the sixths. 1, 2, 3, 4, 5, 6. Yeah, there we go. Here's 1/6. There's 1/3, 1/6, 1/3, 1/6. Clearly 1/3 is greater than, and that's not what they're saying here. So this is wrong. My correct answer is right there. Beautiful. Next question. What is the decimal name for this fraction? Yes, we can read this as 55 out of 1,000. Like that. That is correct. Absolutely. But we want to read it with that right? The denominator is always the denominator, but with a at the end of it. So 55 thousandths. Okay. So decimal. How would I read that? Well, 55 thousandths. Got to make sure that 55, the very last place value, is in the thousandths. 55 thousandths is 55 thousandths. It looks like this. If you chose A, that's a really easy mistake to make. And just by comparing these, we can see what mistake you made. You forgot your placeholder. And actually reading this number, it's not 55 thousandths, it's 55 hundredths, because that's the very last place value the number's in. So 55 hundredths. 55 hundredths is literally 10 times bigger than 55 thousandths. Okay. Moving on. 7. Which comparison is correct? And now notice, not only are they comparing fractions, but they're comparing decimals to each other. Holy smokes. And again, it's really easy to compare numbers when they have that same denominator, when we're comparing the same size of chunks, essentially. So let's do that right now. 1/100th compared to 1/10th. I'm going to convert these both into decimals. So 1/100th as a decimal looks like this. And then I already have 1/10th. So what's bigger, 1/10th or 1/100th? Well, if I was putting something in the tenths, I'd rather have a tenth of something than 100th. Okay. I could also say, like, hey, these are tenths and these are hundredths. I don't like that. Let's make this into hundredths. 10 hundredths is bigger than 100th. Okay. I could also compare this as fractions. So 100th compared to 1/10th. Okay. These are different denominators. Let's make them like fractions. Multiply this guy by 10. Because 10 times 10 is 100. 1 times 10 is 10. Cool. So I can see that 10 hundredths is greater than 100th. Boom. Moving on. Down here, 20 thousandths compared to 5 hundredths. Yuck. They are not like. They have different denominators. So let's do our best to make these have common denominators. 20 thousandths compared with 5 hundredths. Now here's a trick we haven't covered yet, at least on the videos. We may have covered this in class. If we did, cool. But whenever I have a numerator that ends in 0 and a denominator that ends in 0, so they're both ending in 0, what you can actually do is just cancel off those zeros. It's like you're dividing both terms by 10. So that turns into 2 hundredths. Okay, that's kind of cool. Comparing 2 hundredths with 5 hundredths, we've got like fractions. We've got common denominator. So now we can for sure say that 5 hundredths is greater than 2 hundredths. Kind of neat. Okay. Another way of doing that would have been timesing both of these fractions by the other fractions denominator. That would have given you some really big numbers, though, because 100 times 1,000, that gives you 1,000,000. Okay, so big numbers. This way is probably a little bit easier, but again, any strategy is a valid one as long as you get to the correct destination. Let's go over here. We're looking at 4 hundredths compared with 100th. Did you just hear what I said? 4 hundredths compared with 1/100th. Which one has more hundredths? Clearly 400ths, okay? So 400ths right here. This has got to be the bigger one. Notice that they're saying 100th is bigger, so this is absolutely wrong, okay? Over here as well. Okay, sorry, I forgot for part B. They said that 20 thousandths is bigger than 500ths. We proved that that's wrong as well. Okay, let's have a look at this last one here. 9/10ths is less than 9/100ths. I don't like that these have different denominators. And of course, 9/100ths as a fraction is written like this. Okay, now even just looking at these, 9 parts out of 100, that's not very much, right? 9 parts out of 10, that's a lot. Like you're getting the most out of that pizza or that chocolate or whatever we're talking about here. So, I mean, just by looking at it, we can say that the 9/10ths is greater than. But again, we do want to have proof. So having that common denominator is really going to help us. So let's multiply this fraction by 10, because I know that 10 times 10 will give me 100, which will be the same denominator. So 9 times 10 is 90. 10 times 10 is 100. And yep, 90/100ths is definitely greater than 9/100ths. So the answer is D. Cool. Last question. Amy wrote a fraction riddle. My denominator is 100. My fraction is equivalent to 700 thousandths. What is Amy's fraction? Well, let's start with the very first clue. My denominator is 100. Okay. And your fraction is equivalent to 700 thousandths. Okay. Well, 700 thousandths. I'm going to go over here with that clue, and I'll just turn 700 thousandths into a fraction. Okay. And we're saying whatever this fraction is, it's equivalent. It's equivalent to 700 thousandths. Okay. Well, how do I turn this denominator, 1,000, into 100? Yeah, you betcha. I'm going to divide it by 10. So whenever you divide by 10, you just lose a place value. That'll make it 100. Got to divide both numerator and denominator by the same thing. 700 divided by 10 is 70. 70/100ths. So here's my answer right there. 70/100ths. Absolutely, that's equivalent to 700 thousandths. But wait a second. Look at this. We've got 7/10ths here as well. What if I divided this by 10? And divided this by 10? Wouldn't that just cancel off these zeros, leaving me a 7/10ths? Is that the right answer? Well, let's keep moving. 7/100ths, well, that can't be right, because if 70/100ths can't be the equivalent, so that one's definitely wrong. I know that. But what about 700 thousandths? They said that the denominator's got to be 100. So it can't be all three of these. Denominator's 100. D is the correct answer. Even though C and A are equivalent to it, the hidden number has to be D because it has this clue right here. Denominator is 100. So boom, there you have it. I hope that helped clear up some things. And if it didn't, right, there's a lot of strategies that I didn't cover for each of these questions. That's okay. Come see me. Come talk to me. I'll help you. That's why I exist. Thanks, guys. Happy studying.